Hi guys, good morning. Hi guys, good morning. Can you hear me? Hello. Yes, guys, good morning. Can you hear me?
Yes, we can hear you.
Yeah. Yes, let us start session. Yes, tell anyone if anyone unable to hear me, just rejoin. Rejoin it session. Rejoin it session. Yes, anyone unable to hear me, just please simply rejoin. Rejoin it. Okay, yeah, let us start. Yeah. So yesterday's session, see yesterday's session, all that Java history completed. Yes, present position of Java discussed. Yes, about future of Java discussed. Yes, Java popularity. Why Java got this much popularity? Yes, about Java popularity and all that discussed. Yes, today let us start with the Java features. Yeah, this topic. See, this is today's topic. Yes, 8.3. Yes, today day 4. Yes, let us start. See, yes, JDK 1.0. JDK 1.0, first version of Java. JDK 1.0, it's a first version of Java released with these features like independent of platform, portability, hook language, scalability, and security. JDK 1.0 released with these below features. First one, independent of platform. Next, portability, hook language, scalability, and security. Let us see all of this. 1 second, let me have some water. Yes, let us see about all of these things. Yes. 1 second. Yes. To understand these all these features, some basics, software basics. Directly may not be understanding these features here. To understand these features, we need some basics. You need to have some basics knowledge, some software basics. Okay, software basics. So once you have that knowledge, then easy to understand this here. Software basics like OS. What is operating system? What is operating system? Yes, how OS behaving? See, when you're running Java program or C program or C++ or Python, any program, when you're running any program, that how that OS is behaving, that OS behavior, how OS is behaving. So when you're running any program, how OS behaving, that OS behavior. Okay, next apart from this, yes, about interpreter. Yes, about interpreter and compiler knowledge. About interpreter and compiler knowledge. Yes, about OS knowledge. Next, about interpreter and compiler knowledge. Okay, yes, Java. Is it interpreter based or compiler based? Yes, to understand that here, yes, you must know what is interpreter, what is compiler. You must have this knowledge here. So what is the difference between these two? That knowledge. Yes, apart from this, yes, about exe file. Yes, about exe file on dot class file knowledge. So once you have this knowledge, then easy to understand all these features here. Yes, apart from this, next about languages. Yes, about languages like yes, low level languages, and high level languages. Low level and high level languages. So once you have this knowledge here, then easy to understand these Java features here. To understand all these features here, first of all, you must have this knowledge. Yes, if you have this basic knowledge here, like voice, how voice is behaving, that voice behavior. Next, interpreter, compiler working, exe file, dot class file, low level language, high level language. Once you have this knowledge here, then easy to understand these features. See, I can explain Java features directly. Okay, I can explain, but may not be understood. Suppose if I'm explaining just only definitions, you can understand. Only definitions you can understand. But my way is not like that. Not definitions, practically in depth I'll explain here. Practically we'll discuss. In depth, very clearly, practically we'll discuss. So for that purpose, you must have this knowledge. Yes, let us start with basics here. Okay. Yes, I'm starting with basics. Starting with basics. Yes, even non-IT background guys also understand these basics here. Yes, non-IT background. Yes, with non-IT background. Okay, just who is having just only Windows voice knowledge, also they can understand easily here. Yes, here I'm expecting only voice knowledge, not more than that. So from you guys, just I'm expecting only voice knowledge, like what is Windows voice, what is folder, what is file. Only that much of knowledge I'm expecting from you. I'm not expecting any C knowledge or C++. Okay, just only voice knowledge, that's it here. So non-IT background, guys also can understand here. Also can understand. Okay. Yes, I'm starting from very basics here. Okay. Yes, non-IT background guys also can understand. Let us start from basics. See here, computer where very scratch. I'm starting from very scratch. Yes, some guys may be wondering. Some guys definitely wondering. Yes, very scratch. From very scratch, I'm starting here. Computer where. Computer where basically two categories. Yes, why I'm starting from very scratch is here. The reason here. See, you must have every knowledge. Yes, not only Java knowledge here, you must have basics knowledge also. See, some guys having work experience for 10 years, but they don't know about some basics. Yes, here most of the software engineers, they don't know about what is OS, how OS is working. See, every day they will work with OS, but they don't know how OS is working internally. See, every day working with OS, every day they will use Windows OS, but how internally working, they don't know. Just you ask who are working on computers since 10 years, how they are working, how that voice is working, voice behavior. Just ask them, just no answer. Yes, yes, interpreter and compiler. Suppose Java guys who are having 10 years of experience, just to ask them, they will learn the proper, yes, proper information about interpreter compiler. They will not explain, they can't explain. Yes, just you ask exe file, what is exe file? No answer. Just you ask about exe file, no one can answer. What is exact exe file? Yes, they don't know. They can't explain properly. Even dot class file, even low level, high level. Yes, even guys are having 10 years of experience also. They don't know about some fundamentals. They are unknown facts. Okay. Yes, here I want to make you perfect, including basics. Okay, once you facing interview, every question you have to answer. That is my intention. That is my intention. Okay, so every question you have to answer, including basics also. You must have the basics knowledge also. For that reason here. So here before going to these features here, yes, today topic is Java features. JDK 1.0, that features independent of platform portability. These features. Today topic is this. Before going to this topic, Yes, let us see some basics. Yes, if you know these basics here, then easy to understand these Java features. So before going to Java, let us start with basics. Let us start with basics here. See, even non-IT background guys also can understand it. There are some unknown facts, basics. Okay, even experienced guys are they don't know about these basics here. Okay, so let us start from basics. Yes, computerware from very scratch started. Computerware. See, computerware basically two categories. Yes, first one hardware. Yeah, that is well known for you. Second one software. Hardware and software. Yes, hardware means these are physical components of a computer. Hardware, these are physical components like keyboard, mouse, hard disk, monitor. Yes, all that hardware components you can touch. All the hardware components you can touch. All the hardware components you can touch here. Okay. Yes. But we are not a hardware engineers. We are not a hardware engineers. Okay. Yes, we are not a yes, we are not a hardware engineers. One second. Yes. See, so this is not required for us. We are not a hardware engineer. We are the software. So let us start with software. Yes, let us start with software. 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 So what is software? See, software in this, yes, everything is program. It's a collection of programs. Software. Yes, it's a collection. It's a collection of programs. It's a collection of programs. It's a collection of programs. Software. It's a collection of programs. Software. It's a collection of programs. Everything is program. All are programs. In software, everything is program. In software, everything is program. Yes. Here, software. This software basically two categories. Software, yes, basically two categories. Basically two categories. Basically two categories. Software basically two categories. First one, system software. Second one, application software. Second one, application software. System software, next application software. Software basically two categories. System software, next application software. System software and application software. Yes, what is system software here? System software. System software. Yes, system software, it interacts. It interacts with the hardware components. It interacts with the hardware components. Interacts with the hardware components. Yes. What is system software? System software, it interacts with hardware components. Interacting with hardware components. System software always interacting with the hardware here. Yes, example, OS, operating systems. Example, operating systems. Yes, example, operating systems. Operating systems and device drivers. Operating systems, device drivers. System software. See, it interacts with hardware components. System software always interact with hardware components. Example, OS and device drivers. See here, OS. OS interacting with hardware components. Next, device drivers also interacting with the hardware components. Of course, device drivers. Device drivers are part of OS only. Device drivers are part of OS. Device drivers are part of OS. Okay. Next, what is application software? Yes, what is application software? Yes, about application software. Okay, system software. Yeah, this one interacts with hardware components. Application software. What is application software? This is yes, application software. This is for the purpose of application development. For the purpose of yes, application development. Yes, application development. For the purpose of application development. Apps. See apps. See in our daily life, we are using some applications. Yes, in our daily life, we are using many applications. Can you tell me some example? Yes, same question already we discussed. Yes, applications examples. Yes, yes, applications examples. What's happened, guys? Yes, already we discussed about some examples.
Facebook steps.
Some applications examples, some examples already we discussed. Share in chat box here. Share box available. Yes, chat box. Here chat box available. Yes. Best example Facebook, right? Facebook. Next WhatsApp. Yes, mostly used application WhatsApp, right? Regularly. Okay. Yes, Facebook, WhatsApp, Twitter. There are applications here. Okay, Flipkart. Flipkart is an application. Okay, next banking apps. Yes, banking apps. Okay, banking system, online banking. Okay, next trading. Yes, trading apps. Yes, trading apps, online services, online trading applications here. Amazon online services, like this many things. Yes, all the applications. Yes, how to develop this kind of applications here? To develop this kind of applications here, we need some software. Yes, to develop this kind of applications, we need some software. Yes, this kind of applications. For this purpose, we need some software. To develop this kind of applications, we need some software. That software is nothing but application software. Application software. Yes, example. Yes, example. Mostly used application software is Java. Java is a mostly used application software. Yes, Java comes under application software. Java comes under application. Java is a application software. See Java. Yes, .NET is application software. Next, Python is application software. Okay, Hadoop is application software. Okay, yes, C language and C++ they're application softwares. Okay, databases like this, all the application softwares for the purpose of developing applications here. So all these application softwares. Okay, see, many technologies we are using in software field. Many technologies, many tools and language packs, many different kind of things here. Yes, many languages we are using. See, many languages. Okay. Yes, many tools we are using here. Yes, many packages. Yes, more than 100 technologies we are using. Some languages and tools and packages, various kind of things we are using. Then exactly which is application software? Exactly which is application software? See, system software and application software. Only two categories. Two categories. Okay. System software OS. OS comes under system software. Only operating system can interact with hardware components. Others cannot interact here. Yes, only OS. Only OS. Only operating system can interact with the hardware. Of course, device drivers are part of OS. Device drivers is a part of OS. That means only operating system can interact with hardware. See, applications are never interact. Application software, these softwares never interact with hardware. Only ways. That means except ways. Except ways. Except ways, all are application softwares. Simple. Yes, simple answer here. What is applications of except ways? Okay. See, application software for the purpose of application development. Application software never interact with hardware components. Only ways interacting with hardware here. So except operating systems, all are application softwares. All are application softwares. All are application softwares. That's it. All are application softwares. So that's about some idea about application software. Java is application software. So our topic is about application software. Java is application software. Okay, fine. Okay, yes. Right. Yes, Java. They are the Java features. Today topic is about Java features. Okay, Java introduction today. Today Java introduction. Okay, so previous all the classes just to course introduction and all that discussed. Nothing. Today actual topic started. Today actual topic, right? So Java features. Okay, yes. To understand Java features, some software basics. There are some basics required about ways knowledge about interpreter, compiler, exe file dot class for these basics. So once you understand these basics here, then easy to understand Java here. So starting basics here. Okay, yes, everyone can understand these basics here. Okay, they are very important basics here. Okay, even fundamentals. There are some unknown facts. Yes, even experienced guys also they don't know about these basics here. Yes, computer web. hardware and software. Yes, hardware, that is not our leave it. Hardware, that is not necessary for us. Software, yes, all our programs. Yes, software basically two categories: system software, next application software. System software, yes, it interacts with hardware components. Example, OS and device drivers. OS and device drivers. Application software, yeah, this is for the purpose of application development. These are the examples, some applications. Yeah, to develop this kind of applications here, we need some softwares. These are application softwares. Yes, application software example, there are some examples here. Mostly used one is Java. Java is a mostly used application software. See, languages and tools and packages, all these comes on application softwares on here. Simple, simply except ways, except operating systems, all are application softwares. Except ways, all are application softwares. Okay. Yes, 1 second. You guys, running notes is not necessary. Running notes is not necessary. Just you try to understand classes enough here. You try to follow the classes, try to watch it very clearly. Just you focus on the class, concentrate on the class. Don't write any running notes. It's not necessary. Already I have prepared. Yes, already prepared. That running notes already prepared. So everything very clearly prepared. So everything very clearly prepared. Here everything very clearly prepared here. See this today topic. Yes, introduction to software. Okay, software is a collection of programs. Yes, software basically two categories. Basically two categories. Yes, system software, application software. Okay, yes. So application software for the purpose of application development. See, except with all our application softwares. Okay, same thing explain document here. Very clearly it says document here. Running notes is not necessary. Every point covered in the document here. Okay, every point. So whatever topic we are discussing in the class here, whatever the topic I'm explaining in the class here, same thing prepared in documents. See, explanation purpose. Explanation purpose. Yes, I'll be using notepad. Sometimes notepad, sometimes word. Sometimes word also. See, word of word. Sometimes notepad, sometimes word. Suppose something like some drawing, some diagrams, something like this. Okay, something like this. Just I'll be using, yes, this word document. This word. Sometimes using words, sometimes using this notepad. Yes, all this explanation prepared very clearly in the document. Just you can follow document here. Just to follow the document. Just you follow the document here. Running notes not all required. You guys don't write any running notes. Wasting of time. Okay, next. Yes, you can't concentrate in the class here. Okay, try to focus on the class. Try to concentrate on the class here. Yes, you guys don't worry. Every topic I'll explain 2 to 3 times. Like a spoon feeding. Even kids also can understand my classes. Like that I'll explain. You don't worry. Okay, simply focus on the class. Okay, yes. Next here. So next, see, system software, there's a ways about ways. Let us see about ways. Yes, how ways is working, that ways behavior. If you know about this ways behavior, then easy to understand this independent of and portability. To understand these features here, you must have that ways knowledge. Yes, ways knowledge means internally ways architecture, how ways is working. If you know that, then easy to understand it here. Now let us say about ways. Yes, about ways. Say about ways. Yes, about ways. Here some question for you guys. Some question. Simple question. Very simple question. Question is can we run? Yes, any program without ways. Very simple question. Can we run any program without ways? Yes, what is your answer? Yes or no? Answer is yes or no. Can we run any program without ways? Very simple question. Please. Can we run any program without ways? Can we run any program without ways? Yes, answers. Yes, Sundar Raman, no. Saurabh, no. Aditya, yes. Bias, okay. Okay. Bias is not a software program. Yes, we'll discuss. Wait, Venkat, no. Yes, here, answer is no. Without voice, we can't run any program. Compulsory voice requires. See, except bias. Except bias. Except bias to run. Yes, except bias to run all programs means software. Yes, bias. See, except bias. Except bias to run all programs. Yes, all programs voice requires. Voice requires. All programs voice requires. 1 second, just a minute. Hello. Hello. Tell me. Yeah, good morning. Tell me. Yeah, just actually I'm in class. I'll call back. Okay. Yes. So except bias. Except bias to run all programs voice requires. What is bias? What is bias? Bias stands for what? Yes, bias. Anyone idea? Can you give the abbreviation for the bias? Abbreviation. Bias. Yes, bias full form. Abbreviation. Anyone can you abbreviate it? Bias. Yes. Bias. Very basic question. Very basic question asked. You are a software engineer, right? What is bias exactly? Of course, I'll explain very clearly. What is bias? Yes, what is bias? Yes, anyone can you abbreviate it? Yes, good. Good, Sarab. Yes, bias stands for basic, yes, input and output system. Basic input output system. Bias stands for basic input output system. So basic input output system. Basic input and output system. See bias. Yes, it's a hardware program. It's a bias. It's a hardware program. Yes, it's a chip level. It's a chip level program. It's a chip level program. It's a chip level program. Bias. It's a hardware program. Yes, it's a chip level program. It's a bias. It's a hardware. It's a chip level program. Bias. See, yes, bias. Bias image. See, it's a bias. This is bias. Bias is a bias chip. It can a bias program. Yes, what is that bias program? What's the role of bias program? Yes, bias. Bias is responsible for what here? Bias is responsible. Bias is responsible. Bias is responsible. Bias is responsible to boot operating system. To boot operating system. To boot operating system here. Operating system. Bias is responsible to boot ways. Okay, bias is responsible. Bias is responsible to boot operating system. Okay. Yes, what is booting process? What is booting process here? Booting. What is exactly booting? Bias is responsible for booting. That's okay, fine. So what is exactly booting here? What is exactly booting? Let us say booting. So booting is a process. Yes, booting. Yes, booting is a process. Booting is a process of loading OS from RAM memory. Yes, RAM memory to hard. Sorry, reverse. From hard disk from hard disk from hard disk to RAM memory. That's it here. Hard disk to RAM memory. Okay. Yes, booting. Yes, booting is a process of loading OS from hard disk to RAM memory. Yes, OS inside the hard disk. Once you power on our system here, so first of all, power goes to BIOS chip. BIOS chip. That BIOS program activates. That BIOS program is responsible to load the OS into RAM memory. That's here. So before going to start OS, first of all, BIOS program starts. BIOS starts. That BIOS program is responsible to load OS from hard disk to RAM memory. Yes, once OS load into RAM memory, your system is ready. Yes. Now OS, where this OS is running? Inside the RAM memory. Yes, here OS running inside the RAM memory. OS running inside the RAM memory. Yes, this OS is responsible to perform any task here. So you can OS, yes, every request taken by the OS only, every request go to OS here. Now this OS is the responsible to run any request here. OS is responsible. Okay, see here, computer is like this. See here, yes. See, hardware, hardware, yes. On top of hardware, operating system, operating system. Yes, on top of hardware, this is a OS, operating system. Okay, see, once OS started, your system is ready. So without OS, no computer. Without OS, no computer. So once OS started, your system is ready. So this OS is running inside the RAM memory. So your OS is running inside the RAM memory, right? Now this OS is responsible to take any request. Yes, any program running on top of OS, like C program running on top of OS, so C++ also running on top of OS, Java program running on top of OS. Suppose Hadoop also running on top of OS. So database also on top of OS here. Even MS Office also on top of OS. Python scripting like this. So everything on top of OS. These are what application softwares. All their application softwares. See, application softwares running on top of OS. All the application softwares. Okay. See, applications are see. Only OS interact with hardware components. Only OS interact with hardware components. So OS is a system software. Yes, OS is a system software. OS is a system software which interact with hardware. Yet these cannot interact with hardware. Yes, all are running on top of OS. Okay, all the application softwares like C++, Java, Hadoop, database, Python, even for MS Office also. Even MS Office also running on top of OS. So all are running on top of OS only. So OS, it's giving platform. OS, it's giving platform. On top of OS, all are running. So OS just it's giving platform. On top of OS, all are running. So OS here, OS is acting like a platform. It's a platform. See what is operating system. See what is operating system. Yes, what is operating system? What is operating system? Yes, what is operating system? Question is simple question. What is operating system? Yes, it's a platform. Yes, it is a platform. Yes, it's a platform. It's a platform. It's a platform. Yes, where yes we can run all the application software. Where we can run all the application software. Where we can run all the application software. Okay, where we can run. It's a platform. So what is base? What is base? It's a platform. It's a platform where we can run all the application software. On top of which all are running. On top of which everything is running here. Without which we can't do anything. Without which we can't do anything. Compulsory ways. On top of which only all are running here. So it's giving platform. Ways giving platform. On top of it all are running. On top of which only all are running. So it's like a platform. It's like a platform. See, Java features. Java features independent of platform. Platform is here's the ways. Java program is independent of platform. Is Java program running on anyways. That's like a fine. How it's made as independent of platform. How Java made as independent of platform. The topic next we'll discuss. So next we'll discuss. Before going to that here, yes, let us finish all these topics here. About ways, about interpreter compiler, about executable dot plus. Let us finish. Let us finish these basics. After that, we'll go to Java. Okay. Yes. Right. Ways it's acting like a platform. It's a platform. See, not only platform here, not only platform. Suppose these programs generating some output. So output of all these programs first of all delivered to OS. Yes, output of all these programs, first of all delivered to OS and then transfer to output device. Finally transfer to output device. So we're reading from the keyboard. Reading from the keyboard. So first keyboard data, input, keyboard. That keyboard data goes to OS. Yes, OS to these programs. That's it here. So between this application software and hardware, there is a OS. Like a mediator. Mediator means exactly we can see it's interface. Interface. So correct word is interface. It's an interface. OS is an interface between application software and hardware components. Okay, it's an interface between application software and hardware components. So next point, yes, it is an interface. Yes, it is an interface. It's an interface. It's an interface between, yes, it's an interface. OS is an interface between this layer, application software layer and hardware, this layer. Application software layer, yes, and hardware components components. So this is just a basic idea. What is OS? Simply answer like this. It's a platform. Next, it's an interface between these two layers. Okay. Yes. Next, one more important point. Java perspective. Some important points. In OS, there is a library. Okay. Yes, that library contains, yes, all input output functions. Library contains all input output functions. Okay. So OS library contains all IO functions, input and output functions. Functions means C language functions. Functions means here it says C language functions. It says C language functions here. C language functions. See, operating systems were developed in C language. Almost all. Okay. Yes, almost all operating systems were developed in C language. Like Unix developed in C language, Linux in C language, Windows in C language. Yes, Mac OS in C language. Like this, every OS in C language. That C language functions. So this library, it contains all the C language functions to perform IO operations. IO operations. IO operations. Okay. See here. So OS with the help of library, it can communicate between application software and hardware components. See, OS using library, OS with the help of library, it can communicate between application software and hardware components. So every OS, see, every OS has its own, yes, its own library, libraries, yes, to communicate, to communicate, to communicate between, to communicate between, yes, to communicate between, yes, application software and hardware components. Every OS has its own libraries. Yes, using library only it can communicate. It can communicate between application software and hardware components. See, suppose Java program running, or C program running, maybe C++. Before going to run all the programs, first of all, these all the programs, first of all the programs, these programs first of all links with OS library. After linking with OS library, then communicates with hardware components. It has to link up. Every program has to link with OS library before going to running here, before going to run it, before going to execution. First of all, linking with OS library, linking with OS library. Okay, see, every program, every program has to link with OS library, link with OS library. Yes, every program has to link with OS library before going to run. Yes, that link may be statically linking or dynamically linking. Statically or dynamically. Suppose if it's C and C++, it's a statically linking. Statically linking. C and C++ statically linking here. Java and Python is a dynamically linking. Java and Python. See, Java and Python both are independent platform, right? How? There is a dynamically linking. Yes, they are, yes, Java program and Python scripting. These are linking to OS library dynamically. Since they are linking with OS dynamically, these are the independent platform. Yeah, the topic we'll discuss next. I'll explain. Wait for some time. Yes, C and C++ statically linking. Since these are statically linking, they're OS dependent. C and C++ OS dependent reason they are statically linking with library. Statically linking with library. Okay. Yes, Java, Python, independent platform reason they are dynamically linking to OS library. Yes, the topic we'll discuss next. Okay. Wait. Just only idea given. Exactly topic we'll discuss. What is statically linking? What is dynamically linking? Okay, how C program working, how Java program working, how Python program working, and all this we'll discuss one by one. Okay, one by one. We'll discuss one by one. Okay, yes. See, every program has to link with OS library. See, every program has to link with OS library before going to run it here. Before going to running here, first linking with OS library. Of linking with OS library, then program execution starts. Okay, yeah, that's all about OS. Yeah, this introduction is enough. So this is about OS. About OS, this introduction is enough here. To understand Java, this introduction is enough here. Okay. See, same thing explain document here. See this OS. All these 4 points prepared in document here. Yes, all these 4 points. Okay. Last point. Try to remember this point here. It's very important. Very important for Java. Yes, every program has to with OS library before going to start execution. Before going to start execution. Linking with OS library. Linking with OS library. Yes, the topic we'll discuss in Java again. Okay, so this is about OS. So this is about OS. Fine. Okay, so about OS discussed clearly. Yes, OS. Right? Fine. So in system software about OS discussed. Next, come to application software. Java is application software. Java is application software, right? Java is application software. Java is application software. So our topic is application software. Java is application software. Java is application software. So our topic is now application software. Yes, let us move to application software. Yeah, this is application software. See, application software, this is basically two categories. Application software basically two categories. So first one front end, next one back end. Front end and back end. Front end, back end. So what is front end? What is back end here? Front end. Front end. This is front end. For example, here, yes, go to training app. Go to training. See here, this is a form, right? Here is a form. We are filling some form, right? Get that form filling. We are filling form, right? And submitting. This is called as front end. So this is front end. Now this front end collecting data from you. Front end data collecting. It's a collecting data. So front end interact with users and collecting data from users and storing to some location. That location is called as backend. Backend. Backend is to store the data. Backend is for the data storage. Front end is collecting data. So this is front end. So this front end collecting data from you, taking data and storing it backend. So backend is to store the data. So backend software. So these are used to store and maintain data. Example, databases and files. Databases like Oracle database, MySQL database. Files means like Windows files, Linux files. HDFS means Hadoop distributed file system. HDFS, Hadoop distributed file system to store big data. To store big data. Okay. Next front end. See, Java is a front end. Java comes on the front end here. Front end. These are to interact with end users. Yes, it collects. It collects data from users, stores in the backend here. So you get this behind of this form, this Java program, JSP. This form developed in JSP. This form developed in JSP. Okay, so JSP is a Java program. So behind of this form, Java program collecting data. Behind of this form, Java program taking your data means Java is a front end. Java comes on the front end here. Java is a front end. So Java is a front end. So let us move to front end. Yes, in front end, again two categories. Again two categories. Language and packages. Language and packages. Package is ready-made one. Ready-made one ready to use like MS Office package. ERP package, tally accounting, they're packages. No programming, directly you can use. Languages, here everything is codes. Or is a programming language, a programming here. Yes, languages. Java is a language. So let us move to language. Java is a language. Okay. See the way of introducing to Java. Just try to observe it. Way of introducing. A computer where hardware, software. So Java is a software. So starter is software here. Software, system software, application software. Java is application software. So moving to application software. Yes, more here. Yes, need front end, back end. Java is a front end. So moving to front end. In front end language and package. Java is a languages. So moving to languages. Now let us say about languages. About languages. Yes, about languages. Yes, about software languages. Software language. What is a language? What's the meaning of language? See, we are speaking many languages. See, in our daily life, we are using many languages. Why? Why is speaking all the languages? Like English, Hindi, Telugu, Marathi, Tamil, Kannada. Why is speaking? Communication purpose. Yes, language. Just it's a media of communication. Language is a media of communication between two persons or two animals or two trees, two living things. Language is a media of communication between two living things. Now come to software. Yes, in software languages, there are two things. First one, computer, computer understandable, computer understandable language, computer understandable language. First one, computer understandable language. First one, computer understandable language. Second one, yes, user understandable. User, yes, we are the users of computer, right? See, we are understanding some language, computer understanding some other language. Okay, so computer understandable language, computer understandable language. Next, user understandable language. Yes, what is, yes, see, user understandable language means like English language. User understandable language, it's English language. Suppose, for example, here, suppose Java program, suppose Java. Yes, it's English language. It's English language. Java program like English language. Okay, suppose similar to C program, for example, C program. Suppose C program, some C program. See, this is like English language. English language programs, English language, C language, Java. Yes, all the English languages. They're called high level languages. Okay, right? Yes. So user understandable language like English language. Yes, what is computer understandable language? Computer understandable language. Computer understandable language. Yes, computer understandable language. That depends on generation of computers. Depends on generation of computers. Generation of computers. Generation of computers. Yes, here one more question for you guys. One more question. One more question. Yes, how many generation of computers? Simple question. How many generation of computers? Simple question. How many generation of questions? Yes, sorry. How many generation of computers? Very simple question. Anyone can answer? Yes. See, this question just you ask 10 years experience in the software field. No answer. I'm sure. Okay. Just you ask. Yes, most of these software experts are they can't give proper answer. Yes, how many generation of computers? Yes, up to ninth generation, Sundar Raman, ninth generation. Yes, you're saying something like I3, I5, I7, I9, something like I11, something like that. You're saying, I think, Sundar Raman. Yes, how many generation of computers? Yes, Aditya, 5 generations. Ankit, 4 generations. Next, any others? Very simple question, right? Yes, you guys are wondering. I think, yes, this is not expected. They are unexpected basics. Okay. Yes, including bias expand, include voice expand here. Very basics explaining here. There are unexpected things, right? Unexpected things. Not expected this much of basics. Yes, how many generation of computers here? Yes, there are 5 generations. 5 generations. 5 generations. 5 generations. Yes, first generation. What is first generation? Yes, Mr. This guy Aditya. He's saying 5 generations. Okay, correct. What is first generation? First generation. What is first generation? Yes, yes, first generation. Yes, vacuum tubes. Vacuum tubes. First generation, vacuum tubes. Okay. Yes, what is second generation? What is second generation of computers? Second generation. Transistor based. Transistor. Transistor. Yes, transistor based. Yes, second one transistor based. What is third generation? What is third generation of computer? Yes, third generation it's a IC based. Third generation is IC based. Integrated circuits. IC based. IC based. Yes, fourth generation is fourth generation. Fourth generation. Yes, fourth generation is a processor means microprocessor. Microprocessor. Okay, microprocessor. Yes, microprocessor. Microprocessor based. Okay. See, all this. Yes, in our engineering we have this subject here. Yes, electronic subject we have vacuum tubes, transistors, IC. Yes, microprocessors. Okay. Yes, next fifth generation. Fifth generation. Yes, is a AI based. Now, which is present generation? Yes, which is present generation? Totally 5 generations. Which is present generation? Fourth one. This is present generation. This is present generation. This is present generation. Yes, this AI based a feature. Feature means don't expect for long periods. Yes, yes, couple of years coming to the market. AI by 2025. Yes, we are going to work on AI based computers. Okay, once you started with AI based computer, yes, our task becomes simple. Much programming is not necessary. Once AI based computer started here, yes, writing programming is not required. Software engineer task becomes very simple. The time task becomes very simple. Okay, see microprocessor based computer understandable language. Microprocessor based computer understandable language. Yes, understandable language. What is that language here? Language is binary codes. It's a binary code. So binary codes, binary codes. Binary code is like a zeros ones format. It's called as binary code. It's zeros ones. Zeros ones format. Yes, A based. What is A based understandable language here? A based computer understandable language. A based understandable language is English. High level language. English. Yes, A based. It can understand English directly here. A based it can understand English directly. Yes, it's simply English. High level language. High level language. Okay. Yes. Now here this is C. Binary code. It's a system understandable language. Okay, this is called as low level language. It's a low level language. Okay. Yes, suppose Java program. It's a high level language. C program, high level language. Python scripting, high level language. So low level and high level languages. Low level and high level languages. Okay, software languages. Software languages. Yes, there is a low level language, computer understandable language, a low level language, user understandable is a high level language. So you can software languages are two categories. Software languages, two categories, two categories, two categories. So first one, yes, low level languages, low level languages, low level languages. First one, low level languages. Second one, yes, high level languages. Low level languages, high level language. First one, low level languages. Next one, high level languages. So what is low level language? What is low level language? Low level language, It's a system understandable language. Low level language. It is a, yes, it's a system understandable language. It's a system understandable language. Okay, it is a system understandable language. Understandable. Yes, it's a system understandable language. Yes, here system means processor. Here system means it's a processor. System means it's a processor. It's a processor understandable language. Okay. Yes, it is. It is in the form of binary code. It is in the form of binary code. Binary code means like a zeros ones format. Binary code. Okay. Yes. Yes, it is called as machine language. It is called as machine language. It is called as machine language. That's it. Okay. Next, high level languages. These are user understandable here. High level languages. High level languages. Not from a single one second. Typing mistake. Yes. Yes. High level language. High level language. These are what user understandable. High level. Yeah, these are, yes, user understandable. These are user understandable. User understandable. One second. They are user understandable languages. Yeah, these are user understandable language. Yes, it's like English language. It is like it's like English language. It's like English language. Like English language. See, Java is a high level language. Python is a high level language. C is a high level language. C++ is a high level language. All these software languages, they are high level languages. They're high level languages. Okay, here one more question for you guys. One more question. One more question. Yes, which is first high level language? Anyone idea? Which is first high level language? Anyone, can you answer this? Yes, which is first high level language? Which is a first high level language? Yes, which is a first high level language? Yes, which is first high level language? C language. C language. C language. Yes, C language. C language is a first high level language. C language. Yes, developed. C language developed in the year 1972. By whom? Who is the developer of C language? Yes, C language developed by whom? Who has developed C language? Yes, by Dennis Ritchie. By Dennis Ritchie. By Dennis Ritchie. Dennis Ritchie. Okay, Dennis Ritchie has developed C language. C is a first high level language. Okay, fine. See, every high level language program, every high level language program has to, yes, has to convert into binary code, system understandable language. Yes, which one will convert here? Someone has to convert C program into binary codes, Java program into binary code. See, Java program, it's English language. This high level language, English language, has to convert into system understandable language like binary code. Next, C program has to convert into binary code. Who will do that? Yes, which one will convert? Which one will convert from high level language to binary code here? Someone required here. Yes, who will convert here? Yes, interpreter and compilers. Interpreters and compilers. So interpreters and compilers here. Interpreters and compilers. Okay. Interpreters and compilers converts from high level language to binary codes. So interpreter and compiler, yes, converts from, yes, high level language. Converts from high level language program to binary codes. Binary codes. So interpreters and compilers convert from high-level language to binary code. Yes, let us see what is interpreter and compiler. Yes, interpreter and compiler. Yes, most important topic. Yes, every software engineer must have this knowledge here. What is interpreter? What is compiler? Okay, let us see about interpreter and compiler. What is interpreter and compiler? Yes, interpreter compiler. Both are to convert from high-level language to binary code. But there is a difference. But there is a difference here. There is a difference. What's the difference here? What's the difference? See, interpreter versus compiler. First of all, about interpreter. What is interpreter here? For interpreter purpose, I'm taking some Python code. Python is interpreter based language. So, what test.py, some Python code. 1 second. To develop the Python applications, we can use PyCharm with IDE. Using this IDE, we can develop this. See, for better understanding purpose, I'm using Notepad now. For easy understanding purpose, I'm using Notepad. C drive, for example. Yes, let us take some other D drive. D drive. Suppose D drive sample folder. D drive sample folder. Let us go to D drive command prompt. Opening command prompt. D colon that will take to D drive. DR. In D drive here there is a sample folder. Where is sample folder of directory. In character interface calling as directory. Yes, here is a directory here. Same thing GA, it's a folder. GA folder, it's a folder. Same thing character interface. This is character interface. CUI or CLI command line interface. Command line interface. Yes, a directory. This is directory. Now CD change of directory. Change to sample. Change to the sample directory. Yes, here no files. No files. Okay, now I'm using Notepad. Notepad s.py. Python script. Yes, no writing Python. Simple script. A equal to 10. Yes, B is equal to some 20 here. Yes, C is equal to A plus B. Just adding two numbers. Print. Just very simple program. Just print. Yes, addition. Addition equal to C. Displaying C. Addition equal to C. Subtraction. Next multiplication. C equal to A minus B. Next subtraction. Subtraction is equal to C here. Next multiplication. A into B. Multiplication. Multiplication is equal to C. So addition, subtraction, next multiplication. Multiplication. Okay. Yes. Very simple program. Save and run it here. Save. Yes. Close. Now here. That Python scripting. Python is an interpreter. Python is an interpreter based language. Now Python interpreter. Now Python interpreter. Yes. Now just is running Python script. Now Python interpreter is going to run the script here. Yes, running script directly. Yes, you see Python interpreter running the script directly. Suppose if it is C program, first of all checking for all the errors, right? First compiling C program. If it is C program, first compilation. After compilation, no errors. Suppose if no errors, then execution. But here Python is not like that here. No errors, checking nothing. Directly execution. Directly executing. Directly executing. Okay, here how this Python interpreter is working. About interpreter. How interpreter is working. About interpreter. Yes, how that Python interpreter is working. Yes, like Python. Yes, all interpreters working same. Yes, working of interpreter is same. Yes, all interpreters same working. Python interpreter or HTML interpreter, JavaScript interpreter, Linux shell scripting, like so many interpreters are there. Yes, working of interpreter is same. See, this interpreter, Python interpreter, how that interpreter is working. Suppose first statement A equal to 10. Yes, next second statement B equal to 20. So A equal to B equal to 20. Yes, A equal to B equal to 20, C equal to A plus B. Print C value. Yes, next C equal to A minus B. Next, subtraction displaying here. C equal to A and B. Next, multiplication displaying. So this is some Python the script code. The code. Python's this code. How this code is working? This code. Okay. Then Python script code. How this code? First A equal to 10, B equal to 20, C equal to A. That code here, how it's working here. Now interpreter, first of all, checking for the first line. So first statement is correct. First statement is correct. Yes, immediately it converts. Immediately it converts that code into binary format. That code converting into binary format, zeros ones format. Yes, converts into binary format. That binary format given to processor. So processor taking that binary format and generating output simply. That's it. That's it. See, next coming statements may be right or wrong. Yes, interpreter never think about next coming statements. Interpreter never think about next coming statements. So this statement is correct. Immediately converts into binary codes and generating outputs. Suppose checking for next statement. So next statements. Suppose next statement also correct. Next statement also correct. Same process. Same. Yes, converts into binary codes. Yes, next statement also correct. Same process. Converts into binary codes. Yes, that converts into binary codes and generating outputs. Yes, after that, next statement. Checking for next statements. Suppose next statement. Suppose something wrong, simply stops. Something wrong with this here, simply stops. I'll show practically. Wait, I'll show. See, first statement is correct. Yes, then conversion and execution. First statement completed. Second statement complete means line by line. First line checking, then execution. Second one checking, then execution. Third one, something wrong, stops. That's it here. Now let us see here. Yes. Notepad. See. Suppose something wrong. Here the statement. Here something wrong. Yes, next here one more error. Okay. Here one more error. There are 3 errors totally. In this program, 3 errors. Okay, now run it here. Run it. See, up arrow key. I'm using up arrow key to get the previous comments. Up arrow key. Up arrow key, down arrow key, up arrow key, up arrow key. Yes, it will maintain the history of comments. See, now running this is, see this, line number 8, only one error. That means any error comes simply stops. Any error comes simply stops. Stop here. So line by line executing here. Yes, here error. Once error, simply stopping here. Once error, stopping here. Now let us correct this error here. Correction of this error. Yes, comma. Save. Save. And run it again. Save, run it again. Yes, run it again. See, again, next error. Means only one error. Yes, it shows only one error. So this one showing only one error here. Only one error. Okay. Now let us correct this mistake also. So this mistake also. Yeah, this is mistake, right? Save. Now run again here. Yes, again same that error. One more error. Yes, next. So that means only one error. This showing only one error at a time here. Yes, interpreter shows only one error. Any error comes simply stops here. Any error comes simply stops. Okay, so this is working of interpreter. Okay, now run it. Yes, fine. So this is interpreter. So working of interpreter is like this. Now let us take compiler. Let us take compiler. 1 second, just a minute. Just yeah, just I'm taking some water. Just a minute. Yeah, that interpreter working. Yes, compiler. Now let us see about compiler. Yes. Suppose compiler. How compiler is working? Yes, about compiler. Yes, about compiler. Yes, about compiler. How compiler work? Compiler. Yes, compiler. Yes, for compiler, for this purpose, let us take C program. Let us take some C program. C program, some test.c. C program. Yes, how C program is working. Yes, how compile is working. See, compiler checking for the first statement. Suppose first statement is correct. First statement correct. Even first statement is correct. No, it won't convert into binary code immediately. No, even statement is correct. It won't convert. It won't convert into binary code immediately. Checking for next statement also. So first of all, compiler checking for the all statements from top to bottom. Checking next statement. Yes, correct. Even correct, it won't convert. So first of all, compiler checks for the all the lines from top to bottom. Checking all the lines. First line, next line. Suppose next line something wrong. Error yet third line. Error yet third line. After that, checking for next statement. Next statement also correct. Then checking next statement. Checking next statement. Suppose next statement also correct. Checking next statement like this top to bottom. Yes, compiler checks the whole program from top to bottom and shows all the errors. Suppose one more error here. One more error. Like this, all the errors from top to bottom. It's checking all the errors. Compiler checks the whole code from top to bottom and shows all the errors. It shows all the errors. Okay. Suppose correct all the mistakes. After correction of mistakes, now recompilation. 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 Suppose when you recompile, no error. 1 second. Suppose recompilation, no error. Everything is fine. Suppose this is fine. Just a minute. Just a minute. Yes. This is no error. Yes, next. Here also no error. Everything is fine. Top to bottom, everything is fine. Top to bottom, everything is fine. Top to bottom, everything is fine. If everything is fine, then compile opens one more file. It opens another file. Just opening another file. It's opening another file. It's opening another file. After opening another file, this whole code converts into binary format. This whole code converts into binary format like zero funds format. Zero funds format. Zero funds format. Whole code converts into binary format. This whole code converts into binary format. And write to another file. This whole code, just 1 second, just a minute. I want to have some water. Yes, this whole code converts into binary format and write to another file. This file is called as exe. This is called as exe file. Exe means executable file. Yes, executable file. It contains completely binary code, system understandable language. Now this exe file given to processor, So exe file given to processor. So processor takes that exe file, executes, finally generating output. Here this is working of compiler. So compiler checks the all statements from top to bottom. Okay, if no errors, generating one exe file. That exe file executes finally. Let me show practically. Yes, let us see practically. Yes, let me show some C program. Let us see practically here. Suppose this is some C program. Here these are same program to add, subtract, multiply two numbers. Addition, subtraction, and multiplying two numbers. See, compile, success, run it. See, first number 10, second number 20. See, addition, subtraction, and multiplication. Yes, how this is working here. See, there are some mistakes. For example, here, some semicolon missing. Suppose here some bracket missing. Suppose here comma missing. Okay. Suppose here some bracket missing. Okay. Next here some semicolon missing. Okay. Yes. Here maybe some double quotation missing. Something, there are some missing statements. Suppose here some bracket missing. Save. This is saved. Now compile. See this. Totally 9 errors. Top to bottom, totally 9 errors. See that errors. Press any key, any key. See that errors at the bottom. 16th line error, 18th line error, 22nd line error, 25th line error. Yes, 27th line error, 31 line error here, 31st, 33, 36, 40. These are all the errors from top to bottom. So these are the errors from top to bottom. Yes, compiler shows all errors from top to bottom. Compiler shows all the errors from top to bottom. Yes, let us correct all the mistakes. Semicolon missing here. Here bracket missing. Yes, here comma missing. Comma missing here. Okay. Yes. Here some bracket missing here. Okay. Yes. Let us recompile. Yes. Save. Save. Yes. Overwriting. Compile. Yes. Still error. Still errors. Okay. Still errors here. See this. Here. So this bracket missing. Here this bracket missing. Error. Yes. Next here semicolon missing. Okay. Next here double quotation missing. Yes. Save. Yes. Compile. Success. No error. No errors. Yes. See, here no errors. If no errors, what happens? Let me show that. Here no errors. Yes. Alt C compile success. Compile success, no errors. Now what happens? Let me show backend. What happens in the backend here? C. C language, C drive, turbo C, bin. Yes, here. Here name of the program for is math.cpp. CPP and C language both are same, both are compiler based. Math.cpp. See here is a math.cpp. Math.cpp. Okay. So there's a math.cpp here. Math.cpp. Okay. See 11:51 a.m. Just now saved 5/5. 5th May 11:51 a.m. Just now saved. Okay. Now see I'm compiling. Yes. Success. Now run. Run. See. Backend something happens. See, observe it here. Backend running. See backend. See that file. Yes, math application is exe file. That math.exe file created. That's it here. So backend.exe file created. That exe file executing now. Yes, that exe file executing now here. That math.exe file executing. Enter first number 10, second number 20. Yes, output addition, subtraction. So what is happening here? It is generating one exe file. The compiler generating exe file, then executing that. So that's a difference between interpreter and compiler. I think you understand, right? Interpreter, compiler. What's the main difference, guys? Yes, interpreter working, compiler working. Very clearly explained here. Can you tell me some conclusion on this? What's the main difference between interpreter and compiler? What's the difference you observed here? What's the difference? See, this is interpreter explanation. Yes, next this is compiler explanation. What's the difference you observed here? Yes, what is the difference you observed? Yes, guys. What's the difference you observed? Yes, no difference observed. Yes, interpreter is like that is your old knowledge. What is the knowledge you have? Your college level, that is your college level knowledge. Now tell me, as per my explanation today, as per this next level knowledge. Yeah, that is your college level. Still you answering only your college knowledge. interpreter line by line, compile total program execution at a time. That is your college level knowledge. Now it very clearly explains some difference. Some difference practically showed. See, Python, that code executing directly. Yes, right, right. Aditya, you were right. See, in C programming, what happens here in the back end, what happens? Here that exe file is showed, right? Very clearly different showed. Exe file difference. Exe file. See here this exe file. See that? Yes, document. See, by seeing document itself, you can say here no exe, but here second file. Yes, you observe second file, right? That exe file. These are main difference. Compiler generates exe file. Interpreter does not generate exe file. So these are main difference. Yes, compiler generating exe file. Interpreter does not generate exe file. Let us see the differences here. The differences, all the differences prepared. Yes, interpreter versus compiler. See, interpreter versus compiler. See, interpreter line by line executing, right? Compiler whole program at a time executing. Next, interpreter result is line by line. Compiler whole output at a time because of exe file executing at a time. Next, interpreter shows only one error. Only one error. Compiler shows all the errors from top to bottom. Main difference. This is a main difference. Yes, interpreter. It will not generate executable file. Interpreter, it will not generate exe file. Compiler, if no errors in the program, then it generates exe file. Exe file. This is main difference. See, interpreter, it always executes source code only. See, this source code executing directly. Source code. See here. Yes, here. Only Python script is .py file. Don't get .exe file. No .exe file. No .exe file. Yes, that source code executing directly. Source code executing directly. But compiler based what happens? Not source code. Exe file executes. It executes exe file. It executes exe file. It executes exe file. See, interpreter based all scripting languages. They are scripting languages. Compiler based called as programming language. Interpreter based is scripting language. Compiler based is programming language. Yes, interpreter based examples. HTML, Perl, JavaScript, Python, shell scripting. These are interpreter based languages. Next, these are compiler based languages. Compiler based language. C, C++, .NET. These are compiler based. These are interpreter based language. See here, simple point here. Simple conclusion. Interpreter based language don't have exe file. There is no exe file concept with interpreter. No exe file. Compiler. Yes. Every program converts exe file and executes. That's it. Yes, main important difference is exe file. Keep it. Yes, keep in your mind here. Remember this. Main difference is exe file. Main difference exe file. Okay. Yes. Now next level changing. Yes, your knowledge next level. Change to next level. Okay, remember this. Main difference exe file. Compiler based generates exe file. Interpreter don't have exe file. Okay, what is exactly exe file? That also we'll discuss. Exe file about exe also we'll discuss. So this is about interpreter and compiler. Okay, fine. So interpreter examples, compiler examples. Okay, fine. What is Java? Yes, is it compiler based or interpreter based? Yes, it's not. Yes, nowhere Java example. Yes, what is Java? That is important. Java, is it interpreter based or compiler based? Anyone idea? What is Java? Is it interpreter based or compiler based? Yes, that point tomorrow we'll discuss. Okay, tomorrow we'll start Java. Yes, after this, all these basics completed here. Today's topic. This is all this today's topic. Software interaction, system software, application software. Next about OS. Okay. Yes, next front end, back end, language, packages, low level language, high level languages. See that. Yes, generation of computers. Okay. A low level, high level languages. Right. Yes, interpreter and compiler. Yes, all that basics. Next, Java. Yes, tomorrow we'll start Java. Yes, tomorrow starting Java. Java, is it interpreter based or compiler based? Next, after about Java features, independent of platform. Yes, now we can understand independent of platform. Yes, all that basics completed. Okay, now we can understand Java features very clearly. Just one day extra explained, that's it here. One day extra to explain about all the fundamentals, just one day extra taken, nothing that here. Yes, they are very, very important fundamentals. Today topic is very, very important fundamentals. There are some unknown facts. Even experienced guys also they don't know about this one here. Okay. So these are unexpected things, right? Yes, this much of level, this much of scratch, I think no one expected from the scratch expand, including bias expand, generation of computers expand, OS expand here, interpreter compare, all that basics here. Okay, so next topic is Java, starting with Java. Java starting. Java. Yes, is it compiler based or interpreter based? Yes, tomorrow we'll discuss. Tomorrow we'll discuss about that point here. Next Java features. Yes, that's all for today. Yes, any doubts? Guys, any doubts? Yes, tomorrow also same link. No change in the link. Tomorrow also same link. No change in link here. Same link, same time. Same link, same time. Okay. Same link, same time. Right? Yes, till now, whatever discussed, everything shared in the WhatsApp. Yes, WhatsApp group. Yes, in WhatsApp group, I have created. Yes, I have created WhatsApp group for our batch. Okay, in WhatsApp group. Yes, all this. Today I will give the drive access. Today, yes, after 1 hour, we'll get the drive access. After 1 hour, I'll give the drive access. Drive. Yes, your drive. This is your drive. Let me show the drive. Yes, today I'll give the drive access. Yes, by 2 p.m. you can go to your drive. You can see your drive here. Yes, your drive. It's asking to log in. Yes, just a minute. Let me show the drive. Yes, this is your drive. Yes, today I'll give the drive access. Yes, recording strike. This is recording strike. Yes, this is your drive. Yes, 10:30. So 1 to 3. 3 recordings are there. Today recording also I'll upload. So how to access this one here? Yes, simple here. First log into your Gmail. Yes, here drive. Yes, open Google Drive. Log into your Gmail. Open Google Drive. After open Google Drive, share it with me. Share it with me. Here you can see like this. Rao course hour 10:30 am. You can see this like this. Here you can see. Share with me. Go to Google Drive, then share with me. Okay. Next. See here. Your group. Yes, daily. Yes, daily videos and documents I'm sharing. Today's also I'll share it. Today's video, today document also I'll share it here. Next, I'll give the drive access. Today, I'm giving drive access to you guys. Drive access. Okay. Yeah. So that's all for today. Still, anyone not share their details? Yeah, this is my WhatsApp number. My WhatsApp number. Yes, 8179189 Still anyone not shared here? Share your details and add to group. Yes, communication is very, very important. Yes, I'll share in the group. Yes, I'll add to group. Take this number. Still anyone don't have this number? Take it. I'll add to group. Yes, still anyone not share your details? WhatsApp group communication. Yeah, okay. That's all for today. That's all. So let us wind up session for today. Yeah, that's all. Yes. Thank you, guys. See you tomorrow.